Okay, let's have a look at a more practical example of this. What I want to create is some kind of grass field. Remember, we had this in the basics course, but there we didn't actually simulate anything. It was really just a copy to points with some orientation tricks. But this time we actually want our grass to collide with this sphere here. So what I did, of course, is just I took a line and I scattered some points on this grid here, and then copied the lines. And because we can't really see the different grass blades very well, I took a color and set every primitive to a random color. And what we then have is this sphere here that will move hand animated through our grass field here. So let's simulate this. And we start with a constraint, of course, and this time, even though I use the hair because it's the quickest way of doing this, I will switch this for now to string. And then, of course, we need a Vellum solver, and that's really all there is to it. And if we run this, we can see something happens, but not what we want. So let's activate the ground position. Let's run it again. And this is what I wanted to show you. All the grass is basically falling down like noodles. So we just created a noodle simulator, which is great, but not what we want here. It doesn't feel like grass. And the reason, of course, is it's too bendy. So what we can do first of all is, of course, we can go in and change our bend stiffness. And let's increase that to something like this. Let's see what happens. And it doesn't look too bad, but what happens now, it's more like uncooked spaghettis. They fall over instantly. So what can we do about this? We can make sure that we actually pin them down at the ground, because currently they are loose, and this is why they just basically fall over. And for this, we can just use a group, for example. And what I want to do is I want to pin the points. Let's call it pin group. And I take a bounding box. And this is a technique we used before. So let's, for now, do this on the kind of the last point on the ground, like this. Let's use that as our pin group for the pin to animation parameter here. There it is, pin group. So that was easy. And you can see they still fall over. And this is kind of the problem we have when we use string, because basically when you, like we saw before, when you have just one point pinned, they can move freely around this point. Now let me show what happens if I switch the string to hair, and you can probably already tell what I'm on about. Now, even though I pinned the same point, there is a certain kind of stiffness and a certain kind of relationship between the elements, so that the grass pieces kind of stay intact. They don't just fall over, because there is a certain kind of stiffness that goes beyond the very first point. So here in this case, this is a big advantage over the string constraint. Nonetheless, there are ways of making it work even with a string constraint, of course, because all we have to do really, let's turn this back to string, we have to make sure that the area that we pin is a bit wider. So we pin the first 2 points, as you can see here. And then even with a string, this should work, because now there is a certain kind of orientation if you pin the first 2 points of the grass. So this looks like this. It doesn't look as nice as the hair constraint, because the orientation is still pretty loose on the top and very hard now on the bottom. So this is why I would not do this, but I wanted to show you that if for some reason you have to do it, then you can. So let's move this back, and let's switch our constraint back to hair. And what we want to do now is let's make this look a bit more like grass. For example, we could give it a nicer color, and we could even put some geometry on it. So for example, with a sweep, we could give it some thickness. For example, with a ribbon, we can make it thicker, as you can see here. There you go. And now it creates some kind of surface. Let's lower the columns for this, because we don't need that much. And we can even, as you know, change the profile with apply scale along curve, and then we can make it a bit thinner at the end. So something like this. So it looks a bit more like grass blades. And now if I run this, you can see that the fact that we have an orientation in the hair constraint is really helpful here, because it means that the blades are kind of oriented in a more reasonable way. So the orientation plays a role in the deformation, basically. Just notice the problem. There is some funky problems with the collision here. So as you can see, maybe it stretches our grass a little bit too much, which is not what we want. And I think the reason here is that our substeps are too low. So let's make sure that the stiffness that we have set here for the bend and the stretch stiffness, especially here, is actually properly calculated. So let's make sure that we give the Vellum solver a bit more substeps, maybe 5, and then we should get a better result. So here we go. This is much better now. With the higher substeps, we get much nicer deformations, and it really looks like grass. So before we move on and we look at an example that I prepared for this that looks a bit nicer, let's actually quickly switch again back to string, just so that we have a better idea what happens with a string and our blades disappear. Why is that? Well, that's because the sweep node uses an orientation to know where the ribbon should appear. So keep that in mind. Whenever you want to use a sweep on a string curve, you will potentially run into this problem that it doesn't really work. In this case, we just have to calculate the orientation ourselves. And of course, we can do this with a polyframe to fix this. And now he finds the orientation, and he properly knows in which direction it should basically extrude our curves. And now this works again. So keep that in mind. When you use a string, you need a polyframe in combination with a sweep. By the way, a polywire doesn't need that. So with a polywire, it would even work without that. But that's just as a side note. So this would be fine as well. So experiment around with this. There are a couple of ways you can do with the curves after you simulated them. But for now, I stick with a sweep for this example. More importantly, what will happen when we simulate this with a string constraint, though, is that our curves are falling over, basically, because, again, the lowest point can move freely, and they will just fall to the side. So, again, a string constraint wouldn't really work well for a case like that. And here's an example of the very same thing, just with a bit more work. And it's the same concept. It's a sweep node used with a hair constraint, and then a little bit of color randomness on top. And then we get a pretty nice simulation of something like grass. Okay, so you can see quite a lot of cool things you can do with hair and string. Hopefully we understand the difference between the two, and we know when to use what. Okay, so thanks very much, and see you later. Cheers.